What's up? I'm Vin, and today I want to show how to use Heron's formula, which is a nice little formula for finding the area of a triangle when you know all three sides. So here's the formula here, and let's look at two examples. So for the first question here, we want to find the area of this triangle. We're going to round to the nearest hundredth. And the area of this triangle, if we write out Heron's formula, is going to be equal to the square root of s times s minus a times s minus b times s minus c. So all of this is under a square root here. And S is the semi-perimeter of this triangle. So what you could do is just define all the terms. We could say here that side A is equal to 6, because side A over here is 6 units long. B is going to be equal to 3, because opposite of vertex B, this side is 3 units long. And then C is going to be equal to 4. So then if we want to find the semi-perimeter, that's going to be equal to 1/2 times, and we just do the sum of these three sides. So we have 6 plus 3 plus 4 like this. And now if we work this out, this is going to be 9 plus 4 is 13, and half of 13 is going to be equal to 6.5. So that's the value of S. So then all we have to do here to find the area of this triangle, so we could say the area of triangle ABC is going to be equal to, we're going to have the square root of S is 6.5, and then we have S once again, which is still 6.5, minus A, which is equal to 6, and then we have 6.5 minus b, and b is equal to 3, and then we got to extend the square root, so we need a little bit more space, and then we have 6.5 minus c is equal to 4. So the rest of this is just calculator work. So let's go ahead and type this in. We have the square root of, and s was once again equal to 6.5, so we're just going to type in, we have 6.5 times, and then we had 6.5 minus 6, that was first. Not that the order matters, because when we multiply all these factors, multiplication is commutative. So we could mix up the order a bit, but we're going to have 6.5 minus 3 next. Close the parenthesis, and then last we have 6.5 and minus 4. So that was the last side for us to subtract here, or to add into the factor here. And now we just press enter, and to the nearest hundredth, our area is going to be 5.33 square units. So once again, to the nearest hundredth, our answer is going to be 5.33 square units. That's the area of our triangle here. So now let's say we have something a little bit wackier like this. We want to find the area of this quadrilateral, and we're rounding to the nearest hundredth. So we know all four sides, and we know one of these angles. So for a question like this, what we could do is we could draw in this auxiliary line, and we're going to connect BD. And what that's going to do is it's going to break this quadrilateral into two triangles. And now what we could do is we could find the area of the first triangle, the area of the second triangle, and then add those two together. So what we can know here is the area of a triangle. We could say, so the area of a triangle is equal to 1/2, and we could use this formula, 1/2 AB sine C. And that would be if you just had triangle ABC off to the side like this. So that's going to tell us the area of the top part. So what we could say here is that the area, and we'll write it down here, the area of ABCD, that's our quadrilateral so far, is going to be equal to 1/2. And the idea is, if I write in all the sides too, A, B, and C like this, the key to understanding this formula is that side A, side B, and angle C form a side angle side connection. So if we look right here, you can see side A, side B, and angle C make a side angle side connection. So when I'm finding the area of this top triangle, notice the side angle side connection is 5, 6, and 100 degrees. So it'd be 1/2, I would have 5 times 6 times sine of 100 degrees. But now what we're going to do is we're going to add the area of triangle BCD. So notice this is, once again, this is for triangle ABD above. But now we're going to find the area of triangle BCD, and we're going to add that right here. So what we need to do is, first we have to know what is the measure of this missing side. And to find that, we could use another formula here. We could use the law of cosines. And notice, once again, we have a side angle side connection. So if I write out the law of cosines, that's a squared plus b squared minus 2ab cosine of angle C is equal to the side opposite of the angle C squared, like this. So I could use that same side angle side connection to solve for the missing side. And I know the letters are not going to correspond here because it's triangle ABD, and this is for triangle ABC. But if I use this side angle side connection here, and let's say I just call this missing side x, what we could do is we could say that side x squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 times cosine of the 100 degree angle. And once again, that's equal to x squared, the side opposite of the 100 degree angle. So now if I want to solve for x, I'm just going to take the square root of both sides, and this is going to tell us what x is. So x equals, and the rest here is calculator work. So now to find x, we have the square root of, and we just type everything in. What we had was we had 5 squared plus 6 squared. So 5 squared plus 6 squared minus 2 times 5 times 6, and then cosine of the angle between those two, which was 100 degrees. All right, and we took the square root of this. So this is going to give us the value of x. Now what we could do is we could just store this as the letter x. So that way, anytime I press x now, it's going to be stored here, and that's just going to make it easier for the final stage. So we'll just write this answer out. It was 8.45, and it was a very messy expression. So 0.969, and this went to 806, and that's where the calculator chopped off. So now what we could do is to find the area of the second triangle, we're going to use Heron's formula here because now we know all 3 sides. And for now, I'm going to leave this as x. But the rest, I'm just going to type into the calculator. So no, this part that's going into the calculator is going to be, we're going to have the square root of, and we have the semi-perimeter s, which we're going to find by doing 8 plus 7 plus x divided by 2. And we're going to have s times, we'll have s minus 8 times s minus 7, and then we'll have s minus x. Okay, because once again, we stored the letter x in the calculator to represent 8.4509, this whole number here. So the calculator is going to take care of the rest. So now if we want to come up with an expression for our semi-perimeter, remember the second triangle, the sides that were given to us were 8 and 7. But then the third side, x, we already found to be this here. So we're just going to add those 3 together. And then we're going to divide it by 2. And that's the semi-perimeter. And we could store that as the letter s for semi-perimeter. So we're going to store it, s is alpha ln here. So now every time we write s, that's going to be the semi-perimeter. So now we can just type in the whole expression here. The area of the first triangle we said was 1/2, and we had 5 times 6, and it was sine of the 100-degree angle. But now for the second triangle, we're using Heron's formula, so we have the square root of, and remember the calculator stored s as the semi-perimeter of the second triangle, so we have s times, and then we had s minus, and it doesn't matter in any particular order which sides we use, but we could say s minus 8. That was the side length of one of the sides. And then we have s minus 7. And then we have s minus x, which once again, x is already stored in the calculator as 8.45, this whole number here. So that's the last one to type in. So when we combine all of this, at the end, our final answer should be 40.77 square units. So now our final answer, once again, we have the area of ABCD, and the calculator did all this work for us, was equal to 40.77 square units.